Have you ever wondered what lies beneath our feet? Beyond the soil, the rocks, and the foundations of our cities, Earth holds a hidden world. It's a world of immense heat, unimaginable pressure, and forces that shape our planet. Join me on a journey to the center of the Earth. We'll uncover the secrets hidden deep within. Our adventure begins with a simple fact. Earth is not a solid, unchanging sphere. It's a dynamic planet with layers, each with its own unique properties. Understanding these layers and how they interact is key to unraveling Earth's mysteries. We start with the Earth's crust, the outermost layer. This is the Earth we know, the land we live on, and the ocean floor below. The crust is surprisingly thin, like the skin of an apple compared to the whole fruit. It's made up of different types of rocks, constantly shaped and reshaped by forces both above and below. The crust is not one solid piece. It's broken into massive pieces called tectonic plates. These plates float on the layer below, constantly moving and interacting. This movement, known as plate tectonics, is the driving force behind earthquakes, volcanoes, and the formation of mountains. Beneath the crust lies the mantle, a vast and mysterious region that plays a crucial role in the dynamics of our planet. This thick layer of hot, dense rock extends to a depth of about 2,900 kilometers, making it the largest layer by volume within the Earth. The mantle's immense heat and pressure create a unique environment where rocks can flow slowly over time. The mantle makes up the largest portion of Earth's volume. Intense heat from the Earth's core, which can reach temperatures of up to 5,500 degrees Celsius, keeps the mantle in constant motion. This heat is a remnant from the planet's formation and the decay of radioactive elements. This heat creates convection currents, similar to boiling water, that drive the movement of tectonic plates above. These currents are responsible for the slow but steady movement of the plates, which can cause earthquakes, volcanic activity, and the creation of mountain ranges. The mantle is not uniform. It consists of different regions with varying temperatures, compositions, and behaviors. These variations can influence the movement of tectonic plates and the occurrence of geological events. It's divided into the upper mantle and the lower mantle. The upper mantle extends from the crust to a depth of about 660 kilometers, while the lower mantle reaches down to the core mantle boundary. The upper mantle, along with the crust, forms the lithosphere. This rigid outer layer is broken into tectonic plates, which float on the more fluid asthenosphere beneath. This rigid layer is broken into the tectonic plates we discussed earlier. These plates are constantly moving, albeit very slowly, reshaping the Earth's surface over millions of years. The lower mantle, hotter and denser, behaves more like a very viscous fluid over long periods. This slow movement is crucial for the transfer of heat from the core to the surface, driving the dynamic processes that shape our planet. At the Earth's center lies the core, a sphere of iron and nickel. This core is the powerhouse of our planet, driving many of the processes that make Earth unique. It's a region of extreme conditions, with temperatures and pressures far beyond what we experience on the surface. The core is divided into two parts, the outer core and the inner core. The outer core extends from about 2,900 kilometers below the Earth's surface to a depth of around 5,150 kilometers. The inner core lies beneath the outer core and extends to the very center of the Earth, about 6,371 kilometers down. The outer core is liquid, a swirling mass of molten metal. This liquid layer is primarily composed of iron and nickel, but it also contains lighter elements such as sulfur and oxygen. The movement of this molten metal is driven by the heat escaping from the inner core, creating convection currents. These convection currents generate electric currents, which in turn create Earth's magnetic field. This magnetic field is crucial for life on Earth, as it shields the planet from harmful solar radiation and cosmic rays. Without it, our atmosphere could be stripped away, leaving the surface exposed to the harsh conditions of space. The inner core, despite being hotter than the outer core, is solid. This is due to the immense pressure at the Earth's center, which is so great that it forces the iron and nickel atoms into a tightly packed, solid state. The temperature in the inner core can reach up to 5,700 degrees Celsius, comparable to the surface of the Sun. The immense pressure at Earth's center forces the iron and nickel atoms into a tightly packed solid state. This pressure is equivalent to about 3.6 million times the atmospheric pressure at the surface. The solid inner core is like a giant metal crystal, with the atoms arranged in a lattice structure. the inner core spins at a slightly different rate than the rest of the planet, contributing to the complex dynamics of Earth's magnetic field. This differential rotation is thought to play a role in the generation and maintenance of the magnetic field, adding another layer of complexity to the already intricate system of Earth's core. Section 5. Shifting Plates and Restless Earth. We've journeyed to the center of the Earth and back. From the molten core to the solid crust, each layer tells a story of immense pressure and heat, shaping the very ground we stand on. The Earth's interior is a dynamic and ever-changing environment with molten rock and metal churning and flowing, driving the movement of tectonic plates on the surface. Now let's explore the consequences of this hidden world. Volcanic eruptions, earthquakes, and the formation of mountain ranges are all surface manifestations of the powerful forces at work beneath our feet. These geological events can be both destructive and creative, shaping the landscape in ways that are both awe-inspiring and terrifying. The Earth's surface is constantly changing, shaped by the movement of tectonic plates. These massive slabs of rock, floating on the semi-fluid asthenosphere, are in a constant state of motion. They move at a rate of a few centimeters per year, but their impact is monumental. Over millions of years, this movement has rearranged continents, created and destroyed ocean basins, and formed mountain ranges. Where plates collide, mountains rise. The Himalayas, for example, were formed by the collision of the Indian and Eurasian plates. This process, known as orogeny, involves the folding, faulting, and uplift of the Earth's crust, creating some of the most dramatic and highest mountain ranges on the planet. Where they pull apart, new crust is formed. At mid-ocean ridges, tectonic plates are moving away from each other, allowing magma to rise from the mantle and solidify, creating new oceanic crust. This process, known as seafloor spreading, is responsible for the creation of new ocean basins and the expansion of the ocean floor. And where they grind past each other, earthquakes occur. The friction between sliding plates builds up stress, which is eventually released in the form of seismic waves. These waves can cause the ground to shake violently, leading to significant damage and loss of life. Earthquakes are a stark reminder of the immense power and unpredictability of the Earth's geological processes. These plate movements, while often destructive, are also essential for life on Earth. Volcanic eruptions, for example, release gases and minerals that are crucial for the atmosphere and the biosphere. The ash and lava from eruptions can create fertile soils, supporting plant growth and agriculture. Over time, ecosystems recover and adapt, demonstrating the resilience of life in the face of geological upheaval. They regulate the planet's temperature, recycle carbon dioxide, and create diverse habitats. The movement of tectonic plates plays a key role in the carbon cycle, as carbon is stored in rocks and released through volcanic activity. This process helps to regulate the Earth's climate over geological timescales, ensuring that the planet remains habitable for life. The continents we live on, the oceans we sail, and the mountains we climb are all products of this dynamic process. The ever-changing nature of the Earth's surface is a testament to the power and complexity of geological forces. As we continue to study and understand these processes, we gain a deeper appreciation for the planet we call home. Section 6. Volcanoes. Windows to Earth's fury. Volcanoes, awe-inspiring and destructive, offer us glimpses into Earth's fiery interior. These fiery mountains occur where molten rock from the mantle, called magma, rises through the crust. Volcanic eruptions can be explosive, spewing ash and gas into the atmosphere, or effusive, with lava flows slowly reshaping the landscape. While often perceived as disasters, volcanoes have played a crucial role in shaping our planet. Volcanic eruptions released gases from Earth's interior, forming the early atmosphere and oceans. Volcanic ash, rich in nutrients, replenishes the soil, making the land fertile for life. Section 7. Life on a dynamic planet. The Earth's interior, far from being a static and distant realm, directly impacts life on the surface. The movements of tectonic plates influence ocean currents, climate patterns, and the distribution of plant and animal life. The Earth's magnetic field generated by the core protects us from harmful solar radiation, making life possible. The resources we depend on, from fossil fuels to precious metals, are products of geological processes that have unfolded over millions of years. Understanding Earth's hidden depths is essential for managing these resources and ensuring a sustainable future. Section 8. Hidden Treasures, Unearthed. The Earth's interior holds not only the secrets of our planet's past but also resources that are vital to our present and future. From the oil and gas that fuel our cars to the metals that form the backbone of our technology, we rely on materials extracted from deep within the Earth. These resources, however, are finite. As we continue to extract them, we must do so responsibly, minimizing our impact on the environment and seeking sustainable alternatives. The Earth provides for us, but it's our responsibility to care for it in return. Section 9. The Unending Exploration. Our journey to the center of the Earth has taken us through layers of rock, molten metal, and unimaginable heat and pressure. We've witnessed the forces that shape our planet, from the slow grind of tectonic plates to the fiery fury of volcanoes. But our exploration is far from over. Each earthquake, each volcanic eruption, each new discovery brings us closer to understanding the complex and dynamic system that is our planet. The Earth holds many secrets yet to be unveiled, mysteries waiting to be solved. The journey continues, and with it, the endless pursuit of knowledge.